Here we go. All right, so today we're learning how to simplify algebraic expressions. So if you look at what this means, you know algebraic expressions are number sentences that have what in them? Letters, variables, right? So the simplifying part is you can combine certain parts of your expressions to simplify them so that you have a neater and cleaner math problem. Okay, so in a number sentence, look at this for an example. This number sentence right here, that expression is 7x plus 9y plus 15. It stops right here because there's a comma. If you look at that, each section between your operations, so do you see how there's an operation right here and an operation right there? An adding and subtracting operation between your 7x, 9y, and 15. Those are called your terms. This is a term, 7x, 9y is a term, and 15 is a term. So in this number sentence, we have a total of how many terms? 3. Okay, so these terms are all different because you kind of treat so let's take 7x, let's take 9y, and let's take 15. When you look at terms, you need to look at two things. You need to look at your variable, and you need to look at your coefficient. The variable is your letter. The coefficient is the number that goes with your letter. So it's kind of like saying I have 7 x's. On the next one, it's saying I have 9 y's. And on the bottom one, does it have a variable? No, because it does not have a variable. We call it a constant. Now, you can only combine terms that are alike. And what I mean by this is constants can go with constants, y's go with y's, x's go with x's, a's go with a's. Whatever your variable is, you can only combine them with terms that have the same kind of variable. If it does not have a variable, like the 15, it can only be combined with a constant, just like itself. Okay, so if you look at that number expression, 7x plus 9y plus 15, are there any terms that are alike? No. You have x's, y's, and a constant. They're all different. Okay, so you need to know what a coefficient is. You need to know what a constant is. Like terms are terms that have the same variable raised to the same power. So we talked about how 7x and 9y were not alike. But if I had 7x and let's say minus 2x, and then adding and subtracting separate your terms. So 7x and 2x are two separate terms. Are they alike? 7x, 2x. Yes. They are. It's like having a hard time like keeping up with me, so we're having like connections being slow, so hang with me. 7x and 2x. So the first thing you need to look at is your variables. Do they have the same kind of variable? Yes. So they are alike. So it's like saying I have 7 x's and I'm taking away 2 x's. How many x's would I have? 5 x's. So when you simplify an expression like this, it would be just like that, 5x. Now, the problem is if we have, let's say we're still using x's and we do 3x squared plus 2x minus 1x squared. Okay, remember terms are separated by the adding and subtracting symbols. Okay, so in that number sentence right there, how many terms are there? There are 3 because the adding and the subtracting separate your terms. There are your terms. You have 3 terms. Now let's see if there are any that are alike. We have x squared, we have x, and we have x squared. Can you just put all of them together? No. This one right here, the 2x in the middle, is not the same kind of term because it is only raised to the first power. Anytime you raise something to the first power, they don't put a 1 there, there's just nothing. But you assume that it is raised to the first power because there's just one of them. So 2x is different than the other terms because it does not have an exponent with it. However, can we combine any other terms? Yes, you can. And you're looking at your variable x's and what they're being raised to. So we have this is x being raised to the second power, and this one is being x raised to the second power. Those are the same kind of terms, right? So then you say, well, how many x squares do I have? I have 3x squares, but I'm going to take away 1x squared. So how many x squares do I have? You have 2, because you go 3x squares minus 1x squares is 2x squares. And then, so we use that one, we use this one. Whatever's left over, you just bring right down. Plus 2x. Okay, are there any questions on that? That would be your final simplified algebraic expression. Can you solve it?
Yeah.
Are we going to get one answer, should I say, at the end? Like one number answer. Can I solve it?
Yeah.
Or do I know what x is? I don't know what x is, so I can't solve it. That's as simplified as I can possibly get it down to, because I don't know what x is. But I can leave it as this expression, knowing that if I were ever given an x value, I could now solve it. Okay, so the next section says identify like terms in the list. So they're just giving you a bunch of different terms, and they want to you to show which ones are alike. So we have 5a, we have t divided by 2, we have 3y squared, we have 7t, x squared, 4z, k, 4.5y squared, 2t, and 2/3 a. So the first thing that you need to look at is your variable and what it's being raised to. So let's look at a. What they did is they just put a circle around the a, and they want to look at all the other terms to see if there's any other variable a that's raised to the first power just by itself. So if you look, can we do the second one? No, it's a t. Moving on. Y squared? No. I'm looking for a. T? No. X squared? No. Z? No. K? No. Y squared? No. T? No. 2/3 a. Yes, these can be combined. Okay, and then down below they just show you which ones can be combined. 5a and 2/3 a. Okay, moving on. The next one is t. Okay, so we're looking for other t's. Y squared? No. 17? Yes. X squared? No. Z? No. K? No. Y squared? No. 2t? Sure. So the ones in this case that are alike, there are 3 of them. 2 divided by t, 7t, and 2t are like terms. Okay, the next one. 3y squared. So we're looking at our variable, y squared. They just did an octagon around them. So we're looking for other y squared. X squared? No. Z? No. K? No. 4.5y squared? Yes. And then the other ones are already taken. So the only 2 y squares are 3y squared and 4.5y squared. Those are the only ones that can be combined. Okay, look at the other ones. X squared. Z? No. K? No. Are any of those middle 3 alike to anything else? No. So you have to leave them alone. They cannot be combined with anything. Okay. Once you identify which ones are alike, in a number sentence you can simplify them down. Okay, so it's like saying on the next example, up on the top of page 27, you'll have to use your book because I'm having problems with Air Server keeping up with me. It shows you how you combine like terms. We have 4 x's, and we're adding 5 x's. So how many x's would you have total? 9 x's. So to combine like terms that have variables, you either add or subtract the coefficients depending on what operation is between the terms. All right, next part, simplify. It says justify your steps using the commutative, associative, and distributive properties when necessary. We have 7x plus 2x. How many terms are in that number sentence? There are 2. We have 7x as a term. We have 2x as a term. Are they like?
Yes.
Yes, they are. So we say I have 7 x's and I'm going to add 2 more x's. How many x's do I have? 9 x's. Okay, that one's all nice and easy because there was only 2 terms, right? The next one is 5x cubed, or to the third power, plus 3y, plus 7x cubed, minus 2y, minus 4x squared. So we have how many terms? 5. We have 5 terms. Okay, so let's just start with the first one. And we are looking just at the variable and what it's raised to. So this is an x to the third power. So we're looking for other x to the third powers. Will 3y work? No. 7x to the third power? Yes. And I'm going to circle the operation that's right before that, because that is going to tell me what I'm going to do with it. 2y? No. 4x squared? Yes, except for I'm also going to circle the operation that is right before it. So right now I'm going to combine 5x cubed plus 7x cubed minus 4x squared. Uh-oh, we made a mistake. If you look in your textbook, I'll make it bigger. Can I circle?
Oh, it's to the second.
It's to the second power. I know it's kind of hard to see.
It looks like that.
Right. So I'm going to just put an x through this because I can't erase it. We're not combining that because 4x squared is not raised to the same power as 5x to the third power. So we can only combine 5x cubed plus 7x cubed is how many x cubes? 12. Because you're going to go 5. I have 5x to the cubes. I have 7x cubes. How many total x cubes do I have? 12. 7 plus 5 is 12x cubed. Okay, I'm just going to draw a line through them. I'm done with them. Now let's look at plus 3y. So I'm looking for other y's. 2y? Yep, and I need to circle the operation that's before it. What about x squared? No. So I'm going to go a positive 3y and a negative 2y. So that's like saying 3 minus 2 is how many y's?
1.
Minus y. All right, and then remember we still have the minus 4x squared because it did not combine with anything else. So I need to just bring that down. Minus 4x squared. So when I'm done, that expression that had 5 terms now has been simplified to how many terms? 3. Okay, look at the next one. We have 2 parentheses, a plus 2a squared plus 2b. Okay, something happens as soon as you get things in the parentheses. Do you remember the distributive property? We need to distribute the 2 into the parentheses. So to do this, you say, what is 2 times a? Just 2a, right? Plus, distribute the 2 to the 2a squared. So it's like saying you have 2 groups of a squared, but I'm going to double them. So how many a squares will I have? 4. 2 times 2 is 4a squared. And then copy down what you have not used, plus 2b. Now we have 3 terms that we have to look at. We have a squares, and we have b. Can we combine anything? No, nothing's the same. So there are no like terms to combine. All right, let's look at this next one. It says, write an expression for the perimeter of the rectangle. Then simplify the expression. Okay, so what are we trying to find? Perimeter, which is what? All the way around the outside. So that's like adding up all the way around, right? So if we did the perimeter starting here, and we're going to go clockwise, it would be h plus b plus h plus b. And then we need to simplify the expression by combining like terms. How many terms do we have? 4. Let's start with the first one. How many other h's do I have? 1 more h. And remember to circle the operation in front of it because it'll tell you what to do. So I have h plus h is how many h's? 2 h's. And then I have a plus b, which can be combined with a plus b. So that's like a 1b plus 1b is
2B.
2b. Can I combine any more besides my 2h plus 2b?
No.
No. So that's your final expression. Can you solve it the way it is? No, because I don't know what my value of h is and I don't know what my value of b is, so I just need to leave it the way it is. Let's do some problems together. Okay, turn the page to page 28. I want to do some of the problems up above together. It just says identify the like terms in each list. So the terms that we have are 6b, 5x squared, 4x to the third power, b divided by 2, x squared, and 2e. So let's just start with the first one. 6b. Are there any other b's? B divided by 2. Any other ones? No. So then to write this, if I were doing this as an assignment, I would go 6b and b divided by 2 are like terms. Okay? Move on. 5x squared. Are there any other x squared?
Yes.
1x squared. If there's nothing in front of your variable, like say how x squared has nothing in front of it, like not having a coefficient, you assume that it's just one of them. Okay? So you would say 5x squared and 1x squared are alike. Are anything else alike? No, there's no other x to the third power, and there's no e's. So there was only two things that we could combine, or two sets. The 6b with the b divided by 2, and the 5x squared with the 1x squared.
Is it recording?
It's recording. Hang on, let me pause.
So, like,
Okay. Let's look at the next one, number 2. We have 12a squared, 4x to the third power, b, 4a squared, 3.5x to the third power, and 5/6 b. Start with the first thing, a squared. Are there any other a squares?
yeah.
We have a 12a squared, and we have a 4a squared. Those are the, so we would say 12a squared and 4a squared can go together. Okay, move to the next one. Are there any other 4x to the third power? Yes. 3.5x to the third power. So you would say 4x to the third and 3.5x to the third are like terms. Are there any other b's? Yes. We have 1b and then we have 5/6 of a b. So you would say b and 5/6 b are like terms. So in that case, all of them could be combined with another pair. All right, so that's how you identify which ones are alike, but then we take it one step further. We need to actually simplify and then justify your steps using commutative, associative, and distributive. I'll explain that in just a little bit. We talked about the distributive, right? Look at the first one, 5x plus 3x. Are they alike?
Yes.
Okay. What would be being combined? A positive 5 and a positive 3 makes how many x's? 8x is what you can simplify it to. Okay. The next one, 6a squared minus a squared plus 16. What are alike? 6a squared minus 1a squared. And then 16 is what we call a constant, because there is not a variable with it. Okay, can you combine the constant with your a squared? No. Constants can only be combined with constants. Okay, I have 6a squares and I'm going to take 1a squared away. Good, I have 5a squares left over. And then copy down what you did not use. So 5a squared minus 16 is your new algebraic expression. Look at, what was that? Oh, you're right. What mistake did I make? It needs to be plus 16. Very good. Okay, look at the next one, number 5. 4a squared plus 5a plus 14b. Are there any other a squares? No. Are there other a's?
Yes. No.
So hang on, let me back up. 4a squared. Are there any other a squared terms? No, I'm moving to the 5a. Are there any other a terms? just by themselves? No. Because remember, can a be combined with a squared? No. Are there any other b's? No. So can you simplify this? No, you would just say this can't, this is already a simplified expression. Okay, look at the expression 1 for this rectangle. It says write an expression for the perimeter of the rectangle, then simplify the expression. Okay, so remember we're doing what? Perimeter. So perimeter is when you do what? Add up all of the lengths of the outside of your figure. So it would be saying 6b plus 5n plus 6b plus 5n. So I have 4 terms. Start with the first one, 6b. Are there any other b's? Yes. What's the other b term? Yeah, a positive 6b. So 6b plus 6b is how many b's? 12 b's. Moving to the next one, we have a positive 5n. Do I have any other n's? Yes, I have another positive 5n. So how many total n's do I have? 10 n's. So that's my simplified expression is 12b plus 10n. Are there any questions on that?